Dear Professor and hello everybody. My name is Rang Hong Yue. Today I'll be presenting the final process that is the comparative analysis of CNN's model on CIFAR 10 and CIFAR 100. So my presentation today involve the topic. Okay, so we're gonna move to the first one. The introduction is motivation. So in this final process, I used the ASI model to classify the image from CIFAR 10 and CIFAR 100 datasets. And the objective here is in order to explore how the piece of code handle with the simple dataset and complex dataset, and to understand how the model optimization improve the, the performance through each version code. And the reason why I choose this topic is because it's a suitable for AI beginner and offers great potential for future development. So look at this diagram. In this final process, I use two datasets, the CIFAR 10 and CIFAR 100, and there's I developed the choice code version. I call version 1, version 2, version 3 by myself. And uh, I use the version to analyze the dataset and then I get the result. And after that, I make analysis. Okay, so we gonna move to the next one. So firstly, I want to introduce my dataset. Okay, the CIFAR 10 with the 10 classes and 32 multiplied 32 image involve 50 50,000 training and 10,000 testing sample, and the CIFAR test with the CIFAR 100 with the 100 classes, and usually the same structure with the CIFAR test, but is significantly more complex, more challenging. And the task here to you know to classify each input image into its correct label. Okay, this is the code version 1 that I developed. So in this version, I used two convolutional layer and C SCD optimizer with the 10 epoch. And because I wanna observe how the pages code handle with the dataset. So that's why in this version I don't use the RR and data augmentation. So look at the table here, the CIFAR 10 with the 63% in accuracy and CIFAR 100 with the 24% in accuracy. So look at the line graph, the training loss per epoch. So the bold line show a gradual decrease as the number of the epoch increase. However, we can clearly see that the loss reduction rate of the CIFAR 100 is higher compared to the CIFAR 10. we can see two lines. Okay, so because this is understandable because the CIFAR 100 is more complex data set. Okay, so we're gonna move to the next one, the version 2. So in this version, I I use three convolutional layer which dropout is 0.3 and a trend optimizer to Adam. And I also increased the epoch to the 20. So after the trends, look at the table. This version can get the highest performance compared to the previous one with the CIFAR 10 with the 73% in accuracy and CIFAR 100 with the 35% in accuracy. So look at the line graph, the training loss per epoch. That show the same trends with the the version 1. Okay, we're gonna move to the version 3. So in this version, I changed the framework from PyTorch to the Keras. And also use three convolutional layer with the dropout 0.5. And especially here I use the data augmentation. So dropout and augmentation can help avoid the overfit for the model. And I also use the fit training function that is available in the Keras framework. And this function really easy and simple to use. Like our report picture below the table, we can see you just need to input some basic information of the dataset. So look at the table of the result. The CIFAR 10 with the 76% in accuracy and CIFAR 100 with the approximately 60% in accuracy. So that's why this version are highest performance among three versions. And in this version, I also create the plots for the accuracy over epoch and loss over epoch and validation accuracy and validation loss for we can clearly observe the the, the performance. Okay, so in here I compare three versions. So we can see in the version 2 I I made several significant change to the structure of code like I use the wrap out, I train the optimizer and so we can see it could get the higher accuracy than the version 1 and especially here version 3. So I make the change I made change almost to the entire structure of the code. Like I changed the framework, I used augmentation. So that's why it's the highest accuracy among three versions. And you know, even though I use built-in training function, is a is a available in the Keras framework, and it can help me save a time while building the code, but it can get the high efficiencies. So especially the CIFR test, CIFR 100 in the version 3 with the approximately 60% in accuracy. So when we compare with the two versions. So it's demonstrating that you know this version can work well with the complex data. Okay, the practical significance. So in the final process, it helped me understand how the AI's model work and how to evaluate and improve the model step by step as personally modified the code. Here are like a framework, the frameworks, so the number of layer, the optimizer, epoch, and it can help me observe their impact to the code. And it also helped me feel more confident to develop large model in the future. Okay, the future improvement. So in my opinion, if we wanna get the highest performance, we can try to use the power model like ResNet or VZZ and use the pre-trained model or increase the number of epoch or use the larger batch size. So especially we can try to use the learning rate scheduler or early step bin. Okay, the last one conclusion. So by developing three version, it helped me understand the difference between the basic code and advanced code. And it's also, uh, I also learned how the code handle with the basic datasets and complex datasets, and I had developed the ability to improve, analyze, and evaluate AI's model in scientific manner. So I told before, each version showed steady improvement as providing the effectiveness of the model refinement. Mm, okay, thank you for your listening and happy to take any question you may have. You can turn contact directly with me through my email here. Okay, thank you.